Hello, and welcome to a basic introduction on the fourth spatial dimension. Let's get started with our first slide, shall we? Before you can start to wrap your mind around the fourth spatial dimension, the entities and kind of light that comes with it, you need to know the differences in the other three existing dimensions. This is the first dimension in a nutshell. Notice how this line only moves from right to left, or vice versa. It only has the freedom to move accordingly on one spatial plane. Imagine this. Let's say that each row of underscores is a piece of paper, which we'll refer to as a 2D plane. So we have our layers of paper, moving from left to right. A one-dimensional entity would only see horizontally or left to right on this paper as if looking from directly above the paper. Now, imagine that piece of paper again. As opposed to a first-dimensional entity, a second-dimensional entity would also be able to see vertically on a piece of paper, as if looking from directly above the paper, looking up, down, left, and right. Okay, in the third spatial dimension, let's say you have a cylinder. A cylinder is really just the object made up of 2D planes stacked on top of each other. Now, to us, we see the multiple of 2D planes because we're 3D entities that make up a 3D object. But to a 2D entity living on that 2D plane, it would just see a circle because it can't see the rest of the 2D planes making up the cylinder. So it will only see the circle that is on that plane. Understand now? Okay, here comes the really crazy part. This is the diagram of the fourth spatial dimension. Yeah, I know. It's confusing. Mind blown yet? Morgan Freeman. Well, trust me, it gets even worse. Let's take our example of how a 2D entity views 3D entities. Considering the 3D cylinder and how a 2D entity would view it as a circle, imagine the same circumstance but with yourself as a 3D entity, and a 4D entity passing through the 3D room you were in as if it was a 2D plane in the past example. What do you think this 4D entity would look like? Well, you probably wouldn't really see him so much as you would just see some random really weird shape of some sort floating through your room. Here's the weirdest part. W represents the fourth spatial dimension in this picture. As you can see, X is, the first dimensional being's line of sight, Y is the second dimensional being's line of sight, Z is the third dimensionals, and W is the fourth dimensionals. Now this raises the question, if 4D entities can pass through multiple 3D rooms at once as a 3D entity can 2D planes, then do these 4D entities have the ability to cross over different time frames appropriate to each room? Many scientists have different theories about this topic. I personally believe they do not have the ability to do that. If a 4D entity crosses over 3D rooms as a 3D entity does 2D planes, then each of these 3D rooms will obviously include space just as a 2D plane does. But is time different on each 2D plane that we view? So why should it be any different for a 4D entity looking over a multitude of 3D rooms? If you looked at a rock, would time be different for each layer being a 2D plane on that rock? Or would time be the same for the whole rock and the space it occupies? Just the same, would we see a time difference in the multitude of 3D rooms the universe occupies? Given these questions, we can successfully estimate that each 3D room will be of the same time frame as the adjacent 3D room. And that concludes your basic introduction on the fourth spatial dimension.